Alright, this is 9.1 Algebra of Functions, function operations. So we have adding, subtracting, multiplying, and division. And it's better to do examples and kind of get the hang of it. So we'll just go ahead and get straight into it. So first example is f of x is equal to x minus 1 and g of x is equal to 2x minus 3. And we have to find f plus g of x. So that is saying f of x plus g of x. So f of x is x minus 1 and g of x is 2x minus 3. So you're just going to go ahead and add like terms. So x and 2x, that's 3x. And then negative 1 and negative 3, that's negative 4. So this is our answer right here. Then we have f minus g. So this is f of x minus g of x. So f of x again is x minus 1 minus, whenever you're subtracting anything, you always want to put parentheses around it. So g of x is 2x minus 3. Distribute the negative. Minus 2x plus 3. And then we're going to do like terms. X minus 2x minus x. And then negative 1 and 3, we could add those and we get plus 2. So this would be our answer, negative x plus 2. Alright, the next thing we're doing is f of x times g of x, so that's just multiplying them. So that's x minus 1 times 2x plus 3. And then here we could use our box or foiling, really anything that you want to use to multiply these. So 2x plus 3, x minus 1. So this would be 2x squared, 3x minus 2 minus 3. We could combine these. So this is 2x squared plus x minus 3. So this would be our answer. Alright, and lastly we have division. So this is the same thing as saying f of x divided by g of x. And we're going to go ahead and substitute x minus 1 on the top and 2x plus 3 on the bottom. Now we just have to make sure that the denominator is not 0. So we're actually going to set it equal to 0 and see what value we get. Minus 3 divided by 2. So next to that function, we're going to say x cannot equal to negative 3 over 2, because if it is, then the denominator will be 0. Alright, and next we're going to do compositions. These are probably, these usually tend to trick a little bit or be tricky. So the first one is f of g of x. It means that we are going to be substituting g of x for x. And then g of f is we're going to be substituting f of x wherever we see an x. So if f of x is equal to x squared plus 1 and g of x is equal to x minus 1, we want to find f of g and g of f. So again, if you look up here, f of g is plugging g into f. So you're going to rewrite it like this. And one thing I like to do is basically wherever there is an x in f, you're going to be replacing that every single x with g of x. So that's going to be g of x squared plus 1. Well, what is g of x equal to? That's x plus 1. So now you're going to be substituting that in. And then you could simplify this. So this would be x squared plus 2x plus 1 plus 1. So x squared plus 2x plus 2. All right, so next we're going to do g of f, which is plugging g into f. So g of f of x, so we're going to rewrite g, and wherever we see an x, we're going to write f of x. So f of x plus 1. Well, what is f of x equal to? X squared plus 1, and then bring that plus 1 down. So x squared plus 2. All right, so those would be our two answers for A. And for part B, they're asking us to find f of g of 2. So that would be plugging in 2 into f of g. So here is f of g. We already found it, so all we have to do is plug in 2 in there. So we're going to go ahead and do that. So wherever you see an x now, you'll replace it with 2. And then you're going to go ahead and add these together. So you get 4 plus 4, 8, plus 2 is 10. So that would be my answer. And then my next one, again, this is g of f right here. So you already found g of x, so now we're going to find g of negative 3. G of f of negative 3. So wherever you see an x, you're going to replace it with negative 3. And that would be your answer. Alright, so this is the last example I'm covering. So example number 3, where f of x is equal to x squared plus 2x, and g of x is equal to the square root of x, and we need to find f of g of x, which is the same thing as plugging in g into f of x. So we could rewrite it like this. And so wherever you see an x in f of x, you're going to replace that x with g of x. So g of x squared plus 2 times g of x. Alright, then we know that g of x is equal to the square root of x. So the square root of x squared plus 2 times the square root of x. Now the square root and the square cancel each other out. So we are just left with x plus 2 square root of x. And that would be our answer.